We're going to talk about the reactivity series of metals. So we've got this over on the left here, and at the top of the table we've got to the higher the most reactive metals. Okay, so that the most reactive metals don't like being by themselves as elements. They want to form compounds, whereas the unreactive ones like silver at the bottom there are quite happy being elements, and they don't combine with other elements to form compounds that readily. So you can see the most reactive metals are the group 1, which are coloured in pink there. So you can see they are. And they're the most reactive because they've all got 1 electron in their outer shell. So for example, sodium is 281. And they've only got 1 electron to lose. It's easy to lose 1 electron, so they're more reactive. And also you probably remember, as you go down the group, they get more reactive because that electron is easier to lose in potassium than it is in lithium because it's further from the nucleus. So the only 3 alkali metals we need to know about are potassium, sodium and lithium here. And as I say, the reactivity, potassium is the most reactive, it's furthest down the group. Now we get a similar pattern occurring with the group 2 metals here, and we only need to know about calcium and magnesium. They're not quite as reactive as the group 1, so magnesium is 282. So it wants to lose 2 electrons. It's a bit harder to lose 2 than to lose 1, slightly less reactive. But the reactivity also increases as you go down the group, as the electrons get further from the nucleus. So that makes calcium more reactive than magnesium. Aluminium is in group 3 over here. So that's 283, that's going to lose 2 electrons, is a bit easier, a bit more difficult to lose 3 than 1 or 2. Aluminium is less reactive than the group 1 and 2 metals. It's still fairly reactive though. And it's right next to this red staircase line, which of course separates the metals on the left from the non-metal elements on the right. Now, we notice there that we've got carbon and hydrogen there, which have been included in the reactivity series, even though they're not metals, and we'll explain why that is the case in a minute, but they're put down there. And the less reactive metals, well, these are all found in the transition metal group. Okay, and we don't really understand the electronic structure of these in G2A level, so but they are less reactive. That's the transition metals there, that block there. Okay, now how do we go about assigning reactivity? Well, let's get rid of this. Right, well, we can do it by looking at the reaction of the metals with water, cold water, as opposed to steam, and also with dilute acids such as HCl, sulfuric acid, and so on. Now, the most reactive metals will all react with water, as we come across in the periodic table topic before. So all the group 1 metals and calcium from group 2 will react with water. So you'll get the metal plus water will form the metal hydroxide, and hydrogen gas. And in the case of potassium, that's explosive with water. Calcium just fizzes away quite slowly. Now, all of those metals, they will also react with acid, but you wouldn't put them in acid because they're so reactive that it's quite dangerous to do that. But they will react with dilute acids. But all of those metals, all the way down to iron, they will all react with acid. Whereas anything below hydrogen in the reactivity series, and of course hydrogen is in acids, we'll come to that later, anything below hydrogen, so that really means copper and silver and gold, these will not react with acids. So that's how we kind of rank them in order. Just to give you an example of a reaction with acid, so you're going to get zinc plus sulfuric acid, and you get the metal, you get a salt of the metal, so you get zinc sulfate, and you get hydrogen gas, and that's balanced there. And as I say, copper, if you put copper into acid, no fizzing, nothing happens. The piece of copper just gets a little bit cleaner. They won't react with acid. Okay, so now we are going to talk about metal displacement reactions, which I've got somewhere down here. Okay, where's it gone? Here. So, a metal displacement reaction. A more reactive metal will displace a less reactive metal from one of its compounds. Okay, so I'm going to talk about, this is quite important in extraction of metals. So the reason why I put carbon in, tend to put carbon in the reactivity series is a lot of metals are extracted from their ores by reacting with carbon. Carbon is more reactive than zinc, iron, copper, and silver, you can see there. And so it will take the oxygen off the metal or off the metal oxide and leave the metal. So for example, if you've got, I'll do it here. So say we get some iron, which is the most commonly used metal, okay? Iron oxide plus carbon will give us iron. The carbon removes, more reactive. It's not a metal, I know, but it was more reactive than iron. It removes the oxygen from the iron oxide and form carbon dioxide. Balance that, we need the 2 there. So that means we're going to form 3 carbon dioxides. Oxygen's are balanced there, and 3 of those, and then we'll get 4 ions. Now, that's pretty important because if you look at aluminium here, okay, so aluminium, if you react aluminium oxide with carbon, nothing happens. And that's because aluminium is more reactive than carbon. So carbon cannot take the oxygen off aluminium oxide to form aluminium metal. And that means aluminium metal you can't extract by heating it up with carbon with coke, which is a cheap way of making metals. If you want to get aluminium, you've got to use electrolysis, and that makes aluminium quite an expensive metal. So you can see if you wanted to extract any metal from its oxide with carbon, it's got to be below carbon in the reactivity series. So zinc, iron, copper, and silver, sodium, potassium, and so on, you can't extract them in that way. Right, let's look at a few examples of metal displacement reactions then. Other ones. So here, what I've got is, I've got a piece of zinc there, zinc metal, in a solution of copper sulfate. Now, copper is less reactive than zinc. Copper sulfate's blue, I've colored it in blue. And if you leave it for a few minutes, what will happen is that piece of zinc will get coated with brown copper metal on the surface, and the copper sulfate blue color will fade because it goes, and what you've got left behind is a solution of zinc sulfate, which is colorless. So wrote the reaction for that. We've got copper metal plus, copper sulfate, aqueous solution, plus zinc solid goes to copper metal solid and zinc sulfate, and that's in solution, colorless solution, and that's balanced. Okay, so that's a good example of a metal displacement reaction. I've got another one here, not quite as colorful. So what we have there is we've got a piece of magnesium ribbon, silvery magnesium ribbon in a solution of zinc sulfate. So if we get magnesium is more reactive than zinc. So it's going to push the zinc out, the zinc sulfate. You're going to form magnesium sulfate. Like that. magnesium sulfate in aqueous solution plus zinc metal. And the zinc metal you will form as sort of like little black particles, very small particles of zinc, look black, they don't look silver, on the surface of the magnesium. Okay, so there's a couple of examples of metal displacement reactions. Now, the reason why we include hydrogen in the reactivity series, so there it is, you can see, and it's just below iron and above copper. Well, I'll show you why. Is if we do this reaction here, and we'll look at the reaction of metals with acids in more detail, but right here I'm going to react zinc again with not copper sulfate, but that H2SO4, which is sulfuric acid. But people quite often say, "Oh, look, it's hydrogen sulfate," but sulfuric acid is what it is. And can the zinc displace the hydrogen? Well, it can, because it's more reactive than the hydrogen, and so you get you'll get hydrogen gas. Sorry, hydrogen gas here, and also you will get zinc sulfate solution. So you can see it's extremely similar to the metal displacement reaction, but instead of displacing in the case of here, the copper, you've got hydrogen. So the hydrogen is behaving very much like a metal there. That's why we put it in the reactivity series. And that also explains why metals below hydrogen in the reactivity series will not react with acids. Okay, so copper and silver will not react with acids because they can't displace the hydrogen out of the acid. They're less reactive than the hydrogen. The reaction with metals with acids is covered in a lot more detail in a later video if you want to look at that.